Welcome to my YouTube channel Love Physics. Today we will study this topic. The topic is the refraction and the spherical surface, and we are taking the convex as a spherical surface. Here, first of all, we will study the case when light ray travel from the rare to the denser medium. Now, first of all, we draw a diagram. Here, as we know, this is the spherical surface, and the surface is coming outside, so this is the surface, convex surface. This is the convex surface, and the line which is passing through this spherical surface is known as the principal axis. This is the convex spherical surface. Convex spherical surface. Okay, dear students, now this is our object O, and here we incident a light. This is the light incident ray OA, and if we talk about the center of curvature for this convex surface, this is the center of curvature C, from where this spherical surface can be made as a complete circle. Now we are taking a normal which is passing through the center of curvature C. This is the normal. Now if the ray which is incident on this spherical surface will be refract, and let us suppose this light refract here, and this is the point I where the image is formed, I. Now as we know, this incident ray makes an angle with the normal, and this is the angle I. And let us consider this OA incident ray is making an angle alpha with the principal axis. In the same way, you are here taking an angle gamma. Sorry, this will be the incident I, so the angle here will be refraction, angle of refraction, refracted ray. This is the refracted ray, and the refracted ray with normal will make an angle R, and this is the angle. We suppose the angle with I will be the beta. This is angle beta, and the angle here, let us consider it as gamma. And students, we suppose here a perpendicular, let us suppose this is N, a perpendicular on the principal axis, and this is the AN ray. Now here we are watching this triangles. There are many triangles in this spherical surface, and here you can see a triangle OA, and this is the C. First of all, take triangle OAC, and here you can say that the angle I is the outside angle, and it will be equal to two angles. Which angles? You can say alpha, this, and this is the beta. If we take angle I, and this will be equal to alpha plus beta. Why? Because the exterior angle will be equal to the sum of two opposite angles, and here you can see alpha and beta are two opposite angles. So now take another triangle and see triangle AIC, because this angle is with the image, so obtain the value of R from here. How can you obtain this value of R with AIC? You can tell here this angle gamma is equal to R plus beta. The angle gamma is equal to R plus beta, so the angle R will be equal to gamma minus beta. So from these two diagrams we have obtained the value of I and the R. Now, as you know, the Snell's law is is 1 mu 2 sine I divided by sine R, and if you take here the angle I and the angle R very small, angle I and angle R very small, then in this case the sine I will divided by sine R will be equal to I by R when the angle I and the angle R are very small. And as you know, angle I and the angle R is equal to alpha plus beta divided by gamma minus beta. So this is the correct form of the I and R. Now here we have written 1 mu 2, which is the refractive index of 1 with respect to the 2, and you can write this in the form of mu 2 divided by mu 1, and this will be equal to alpha. This is the equal to alpha plus beta. Here the mu 2 divided by mu 1 will be equal to, in this form, C OAC, triangle OAC, angle I is equal to alpha plus gamma. So here it is not beta, it is gamma. So write mu 2 alpha plus gamma, and this will be alpha plus gamma divided by mu 1, and this will be I divided by R, this will be gamma minus beta. Now you can do it as a cross multiplication. You see mu 2 gamma minus beta will be equal to mu 1 alpha plus gamma, and if you open it, you can write mu 2 gamma minus mu 2 beta is equal to mu 1 alpha plus mu 1 gamma. Now dear ones, you see here the mu 2 gamma and here is mu 1 gamma. So put these two terms together and it will be mu 2 gamma minus mu 1 gamma, and take it on the another side, mu 1 alpha plus mu 2 beta. Now see, if you take gamma as a common, you can write it mu 2 minus mu 1, and the gamma is common, you can write here mu 1 alpha plus mu 2 beta. Now students, see here the value of alpha, beta and the gamma in terms of the angle. What will be here? See, if you take as an angle alpha, so you will say tangent alpha will be equal to the alpha. See, in front of the alpha there is an, and the tangent will be the perpendicular upon base. This is the an base, an perpendicular, and the on is the base. And here once, if you see this point, this is the pole, and you can say on is approximately equal to op, so you can write here an divided by op. Now talk about the beta angle. If you take the tangent beta, see here the tangent beta, and you take, if the an as the perpendicular, then the base will be ni, so this will be an divided by ni, and as you know, this is the ni will be equal to the pi, so here you can write an is nearly equal to pi, an divided by pi. Now tangent gamma, see here the gamma, and the angle is in front of this, the side is an, this is the perpendicular, and the, you know, the tangent is perpendicular by base, so this is an the perpendicular, and the base is divided by nc, and you can say the nc is nearly equal to pc, so you can write an divided by pc. So put these all three terms here in this equation, and you can say mu 2 minus mu 1, mu 2 minus mu 1, gamma will be equal to this an divided by op, because the tangent alpha will be nearly to alpha, because angle are very small. If the angle are very small, then we will write an divided by op as in the form of gamma. So tangent gamma will be an divided by pc. So you will write pc. Now mu1 alpha, see here alpha is, if we take tangent alpha nearly equal to alpha, then the this term will be, alpha will be equal to an divided by op. So here an divided by op, and the mu2 beta will be equal to an divided by pi. So this is the term where you can write this. Now see an, where is the an is the this side an, and here you can see an. So my dear ones, if you take common mu2 my mu1 an divided by pc, and if you take mu1, if you take the an as a common, you can write mu1 divided by op plus mu2 divided by pi, and here an will be cut. You can see here mu n will be cut. So mu2 minus mu1 will be divided by pc, and here mu1 divided by op plus mu2 divided by pi. Here you can see the pc is what? This pc is nothing but the value of r, radius of curvature. In a lens, you can say the line joining the p pole to the center of curvature is the radius of curvature. So this is the mu2 minus mu1 divided by r, and as we know this is on the another side, so we will take r as the positive, and mu1 divided by op is in the left hand side. So, and as you know, this is the distance of object from the pole, and this distance is known as u. This distance is known as u. So this is the u, but this is the on the left hand side of the lens, so we take it as a negative term. Now talk about the pi. Here you can see this p and this I. What is it? This is the value of v. V is the distance of the image from the pole of the lens. So this is the v, and because this was on the right hand side, so we will take pi as a positive term, and this will be the result for the refracting surface when the light ray travel from the rarer to the denser medium. This is the correct form. Here you can explain it in this way.